Welcome to Enots Engineering, I'm Alan. Today I'm looking at the speeds of the lathe. Ever since I've had my Boxford, which is over 50 years ago, it's always been hesitant to run at the fastest speed. Especially in cold weather, you need to warm it up, get the motor working, get the bearings warm before it would even get anywhere near top speed. So today I'm looking at the speed of the chuck and the pulleys, and to do that what I've done is bought this hall sensor and a digital readout. So I'll be wiring these up, setting it up on the lathe temporary to see what speeds I'm actually getting and whether there's a problem with the motor or whether it's something else in the system. So let's go into the workshop, see how we do it. Well, today I will check the speed of the lathe, and to do that I've bought a digital rev counter. Here I have a battery pack with some batteries in to give me power, some connection blocks to connect the wires to, a screwdriver, and this is the rev counter. And this is a panel mounted rev counter. So with this you get the digital display, connecting plug, the proximity switch, a magnet. So what I want to do first is just see if the display works. I've connected the battery, connected the proximity switch, switched the power on, and the display is reading 0. If I pass a magnet in front of the sensor, you'll see on the back there the LED lights, and every time that lights it takes a reading, a pulse, and you can see that the rev counter is indicating the number of pulses and converting it to RPM. So that all works. We'll now look at the wiring diagram. If you didn't get the diagram with the part, you can get it on the internet. So the brown wire of the sensor goes into number 1 and a positive supply. A negative wire goes into number 2 from your power supply. Onto number 3 is the blue wire from the sensor. And number 4 is blank, nothing, not used. And number 5 is the black wire from the sensor. The voltage should be, it says on here, from 8 to 24, but I've been running this on 6 volts and it still works. Now I need to go into the workshop and set it up on the lathe, then check the actual speed against the speed recorded on the data plate. On the lathe I've fitted the magnetic base to the top slide. Holding that in the end is a washer, and then in the washer is a proximity switch. In the chuck I've fitted a metal bar, and I've just clamped a magnet in between a washer and the bar. So here's a magnet at the bottom. As I rotate the magnet, you can see on the top here the proximity switch LED lights up as it passes. Just turn the light out. This magnet is a flat magnet and not the one supplied with the kit. So if I put the lathe on, you can see the switch pulsing. That pulses each time the magnet passes a switch. So that's the reading without it running. So I switch the lathe on. This is on the slowest speed. According to the plate, this speed is 210. You see that's given me a reading of 224. This is with the lathe cold. So if I change the belt to the next speed, that's set to the speed of 340. Coming up to 364, 65, 365. So I'll change the belt again to the next speed up, and this should give a reading of 540. That's set to a speed of 850. Stabilised now at 873, and it should be 850 according to the plate. So we'll change it now to top speed. That's on the fastest speed, 1400. Now I've set it at the slowest speed, which is 210, and engaged the back gear, so that should now give me a speed of 40. Now I've changed the speed again, it should give me now 66, still in back gear. The machine's a lot noisier in back gear because obviously it's engaged an extra 2 gears in the head, which gives a lot more noise. I'll just try it on the next speed up just to get an idea of the difference. So now this should be a speed of 105. So that's running at a speed of 113, just over. I'm just trying to think where I can fit the Hall sensor on the lathe. That's the Hall sensor. It needs to be somewhere where it's giving you a true reading of the headstock speed. So really, the only place I can fit this Hall sensor is somewhere on the main spindle. You could fit it somewhere in the cabinet beneath, but the problem is you'll never get a true reading of what speed the chuck's rotating at, because all these belts are giving different speeds. So you've got the motor at the bottom, that drives that shaft across the middle, where you've got your 5 speeds on the end. So anywhere, if you put the sensor on that shaft, it would only be telling you what speed the motor's going. Second shaft under here, but obviously the speed of this is not the same speed as the headstock, because this will vary depending on what pulley you're on here, and also you have another pulley that goes up to the headstock. The only way you can get a true reading of the spindle speed is to fit the sensor directly onto the spindle. On this end of the spindle there's nowhere you could put a sensor. You'd need a bracket to fit this on, and the other thing is you need a magnet, and if you've got a magnet on this side of the chuck you're bound to get swarf collecting on the magnet. That's going to cause problems. So there's nowhere here you can put a sensor. So the only other part is on the other side of the headstock where the gearbox is. So on this end we have the gearbox. So there's no point in fitting it on any of these gears because it's not the correct speed. This is the only part you've got here where you can fit. So that's what we need to do, is fit this here, and to do that we need to make a bracket and fit a magnet somewhere there, and that way every time the spindle moves you'll get the true reading of the speed of the spindle. I've just fitted this piece of steel in, and that will touch on the saddle, so I have a reference point when I'm unscrewing the nut the other end. This will stop the spindle turning. Next job is to move the gears out the way. Remove this part. There's a cap head underneath here. That piece holds it in underneath. Now you should be able to move this out. The next job is to unscrew this. And what I've done is, because the chuck's held with the bar in it so it won't turn, or I can locate it back into the same position, I've removed 2 grub screws from this ring. They have a brass washer on the bottom that grips on the thread to stop it moving, and now I'll put the spanner on to remove this ring which puts load on the bearings. There's a spanner. It's just a large socket with 4 holes around the outside, and you put pegs in. Around the outside. I only need 2 now because it's not that tight. Take this off. Watch you don't lose the 2 brass inserts are in the grub screw holes. So what I'm thinking of doing is drilling a hole in here and putting the magnet in, making a bracket come off here to hold the sensor. And what I did before I removed it, I scribed a line across the edge that lines up with a red mark on there, so when I put this back I can put the tension on the bearings, or the load on the bearings, back to where it was before. First thing I want to do is get the centre of the part so I can then spot drill and put a 10mm hole in. So I'll put my centre finder in. Zero my axis. .735, so if I move it back then to 0, that should be the centre. So I fitted the spot drill in, and I just want to drill down 4.5mm. Now changed to a 10mm end mill to give me a flat bottom to the hole. The next thing I want to do is drill a small 5mm hole straight through so that when I put the magnet in I can push a small rod through from behind to get the magnet out again. On the magnet I've put a red mark on the one side because the sensor only works with the magnet facing a certain way, so I've marked the way that it works, so when I fit this into the hole it will face out. This is the finished ring. That's the hole I've made for the magnet. Oh well, that's it for today. We'll finish this in part 2 and we'll see you next time on Enots Engineering.